All right, finance students, we are on practice problem 5.5, continuing our discussion of time value of money calculations. We just recently looked at 5.4, which was calculating future value of a single deposit with non-annual compounding periods. We're going to look at finding a present value. And we're actually going to do two of these problems here on ICA 5.5, calculating present value for non-annual compounding problems as well. So for this one, let's start with the first one. You need $100 3 years from now. How much do you need to deposit today? Keyword is today. That tells us we're looking for a present value. Assuming all your money will earn 6% compounded monthly. So the first thing we know is we want to gain $100 in the future in 3 years. But here's the thing, we're getting a monthly compounding. So we have to adjust our rate and our number of periods for both of those things. In order to do that, let's do some preliminary calculations. We know this investment is going to go for 3 years. We know we have a 6% annual rate. And if it's compounded monthly, that means there are 12 compounding periods per year, 12 months a year, 12 compounding periods. Okay? So the first thing we need to do is adjust our interest rate. And to do that, we take our annual rate and we divide that by the number of compounding periods per year. So we're going to take our 6% divided by 12. So that gives us about a 0.5% interest for monthly compounding. That's what we have. All right. Second thing we need to do is adjust our number of periods. So number of periods, to do that, we take the number of years that we have and we multiply it times the number of compounding periods per year. So if we have 3 years and we get paid interest 12 times a year, that should give us 36 compounding periods in this investment. Now that we've adjusted our interest rate and our number of periods, we can run our present value function, our PV function. We can calculate rate. We input our rate, we input our number of periods, no payment. We input our future value, close the parentheses, hit enter, and that will give us a present value. We would have to deposit $83.56 in the bank today in order to have $100 in 3 years with compounded interest monthly at 6% per year. Okay, so that's the first one to do it. Now, I want to look at the last one down here, and this refers and helps us understand timelines a little bit better. So the question says, your parents invested $50,000 15 years ago at 9.5% compounded quarterly. Now, a problem like this would probably be a good idea to write out a timeline, because what we see is we have this investment of $50,000 that happened 15 years ago. Now, what this shows is a problem in which our future value is actually associated with today, and our present value is associated with 15 years previously. What this indicates, and what this is a good reminder of, is that when we do time value of money problems, present values always come before future values. Let me say that again. Present values always come before future values. However, a present value does not always mean today. Does not necessarily always mean today. Usually does, but not always. So you have to be very discerning and read the problems critically, and to make sure you understand where all your numbers and your inputs go. So what we have with this one is we have a present value of actually $50,000 that they invested 15 years ago. So that's the present value on the timeline. That would come first. And what we're looking for is our future value. It's what they have accumulated as of today. Even though today is not present value, today is future value. So once we've established we're looking for a future value, we're given the present value, we can enter and figure out everything else that needs to go into this future value problem. So years, we know we have 15 years. We know we have a 9.5% annual interest rate, and it's compounded quarterly, which means 4 compounding periods per year. So we go back through to change and adjust our interest rate for non-annual compounding. We take our annual rate and we divide it by the number of compounding periods per year. So that gives us about a 2.375 quarterly rate. And number of periods, we have 15 years times 4 compounding periods per year, which would give us 60 times in this 50 years that we would get paid interest. So now that we have that, we can run our future value function. We have our rate of 2.375 rounded to 2.38. Number of periods is 60. Not a payment for this problem. Present value is $50,000. So we see that with a deposit or with an initial investment of $50,000 15 years ago, they should have $204,450.37 in the bank today. So just a reminder, present values always come before future values, but present values do not necessarily mean today.